Alright, this is attempt number 4 of filming this video. It's going to be not perfect. I'm going to probably make mistakes. The joys of trying to film a video with 2 different pieces of technology and a microphone, it's been a bit of fun. So hopefully we're at a point where we are all good with it. We'll see how we go. Let's try and crack into it so I don't waste too much of your time. Let's have a look. The question is this. It says, a sculpture in the city mall is a form of a truncated cube is shown. An expensive coating is to be applied to the outside of the truncated cube in an attempt to prevent vandalism. Determine the area to be coated using vector methods and show full justification. So we're going to use vector methods that we've sort of used in class to be able to try and figure that out. This is one of those problems that I like because you can break it down into steps. It's the joy of any problem that looks difficult. You're like, where do I kind of start? You know how to do everything that's required that I'm about to show you. It's just about putting all of those steps together. Hopefully that makes sense, but we'll see how we go. I've redrawn my little cube just over here. So it looks like this here in a fashion that kind of makes sense to me. I've chosen some points. So here's my origin. This is point A, point B, point C. I've drawn these things in here. The one thing I haven't drawn in is this one here has to be 1.5. It's just going to be in red for the moment, just so I remember it. I'm just going to zoom out a little bit so I can see what's going on. The other thing I've done there is also I've chosen my axis system. So in my head, hopefully you can kind of imagine this in your head as well. This point from origin to this point to the other side of the cube is going to be the X axis. This one over here is going to be the Y, and then this one's going to be the Z, I, J, or K, interchangeably. So the first thing we're going to do is we're going to go ahead and just put in a equation or a rule, if you like, to try and figure it out. Keeping in mind we've got to figure out surface area. So what I'm going to do is going to say total surface area here, total surface area of this truncated cube is going to be equal to the surface area of the untruncated, and then I'm going to go minus the surface area that's lost plus the truncated surface. Straight off the bat, you should be able to do the surface area of the untruncated cube, so the whole thing. So surface area of untruncated is going to be equal to, there's 6 sides. To figure out the area of one square, it's just going to be side by side or side squared, whichever way you want to do it. So this is going to be 6 times, so that's my 6 for the 6 sides, 2.5 squared, because each side is 2.5. So 2.5, 2.5, I'm going to square that. 2.5 squared, which should give me an answer of 37, not 35, 37.5 square meters. Now, tech active question, keep that in mind, because we'll definitely need that later on, but tech active, chuck that in your calculator, good to go. Surface area lost. This is where it might get a little bit tricky, but when you're trying to figure out the surface area of a triangle, or just the area of a triangle, a half times base times height. I'm just going to put this to the side so you can kind of see it. Half times base times height. I'm going to look at this one just here. So the distance from the base to this point here is a meter, or 1. The distance that's been lost is from here to this point kind of here, if you can kind of imagine that in 3D space. So this point just here, so that's going to be 1 minus 2.5 is going to be 1.5. So if I put this over here in my little side math part, 1.5 times the base, this is going to be 1.5. That's how much I've lost. And then this part here, if I'm imagining this triangle that's sort of coming, this part here that's been kind of shaved off, I'm going to look at this part here. So this distance from this point here, C, to here is going to be 2. So it's going to be times by 2. So then essentially this becomes a half times 3. There we go. All right, so over here, I'm going to do them all together. So this is a half, 3 plus, if I look at this distance, where are we? This distance from A to here, that should be 1. And then that triangle that's sort of made in there will be 1 times 1 times 1.5, because there's 1.5. I should have known that because I just did it. So 1 times 1.5 should give me 1.5. And then the distance from here to there is going to be 1, and then this distance is going to be 2. So 1 times 2 is 2 plus 2. Bam. Done. Again, calculator, chuck all that in. It's going to be 3.25 square meters. Cool. All right, so we found that one. Now, we need to figure out this triangular truncation. We're going to do that using vectors, starting at our origin and then going ahead and having a go at that there. So let me just come over here and have a look. I might just do it over here, I reckon. So I've got my A. If I go triangular truncation, I've got my A. Now, if I come back over to the point, or over to the cube that I've made, this O, remember X, Y, Z. So if I think of A has gone 0 on the X-axis. It's gone 1.5 on the Y-axis and 2.5 there. So here, back over at my thing, it's going to be 0, 1.5, 2.5. And if you want to put it as a position vector, you're going to go origin to that one is going to be equal to 1.5 J plus 2.5 K. That's my first one. Point B, again, we just come back over and have a look at it. So we have B. B is 0 on the x-axis, or 0i. It's 2.5 on the j-axis, or the y-axis, and then 1 up. So over here, we are going to put in 0, 2.5, 1. Position vector there is going to be 2.5 j plus k. Perfect. C, you can go and have a look at it yourself, but C is going to be 2 on the x-axis, because it's 2 from this point here, because it's 0.5 there. So 2, and then it's going to be 2.5 and 2.5. So back over at my thing, I'm going to have 2, 2.5, 2.5, and then that's going to be from O to C. I'm going to have 2i plus 2.5j plus 2.5k. Perfect. So we've got that all sorted out now. Now, the area of a triangle when you've got 3 points is this. The area of the triangle is going to be equal to a half times the magnitude of AB cross multiplied with AC, where AB is going to be equal to B minus A, which is going to be 2.5 plus 1. Let's put that in, put that properly. 2.5 J plus K minus 1.5 J plus 2.5 K. So here we're going to have J, and then we're going to have minus 1.5 K. And then AC is going to be C minus A. So here we're going to have 2i plus 2.5j plus 2.5k minus, I'm looking at A, 1.5j plus 2.5k. Cool. So then AC will be 2i plus j. Cool, so we've got that. So back down here, we can do some work with that. So here, remember, tech active, use your calculator. I, j, k, and then you're going to have 0, 1, 1.5, but it's going to be negative 1.5, and then 2, 1, 0. Do the cross multiplication on your calculator. Save you a heck of a lot of time. Magnitude 1.5i minus 3j minus 2k. Magnitude square root 1.5 squared plus negative 3 squared plus negative 2 squared. And then do half of that and you get 1.953 square meters. Cool. So we're at a good spot because we can now figure out the total surface area. So total surface area is going to be equal to, pardon me, this part up here, which is going to be 37.5 minus the area loss, which is 3.25, plus the truncated area, which is 1.95. We're just going to go 2 decimal places because that's fine. And then you are going to have an answer of 36.2 square meters. Let me zoom out so I make sure we're all good and we're all in the same spot. That's very good. Okay, so you can have a look at that now. First step for me was to go and have a look at this one over here and just have a look and make sure that I've got a rule, which is kind of handy. I figured out the surface area of the untruncated. You guys know how to do that, right? It's not too difficult to figure that out, hopefully. You're all good with trying to figure out that surface area. The surface area lost, just trying to visualize in your head how to put those triangles, kind of where they sort of fit. I found that doing it like this here makes it significantly easier to understand than this one here. Because I found that decently difficult to understand. But when it was in this form here, I'm like, okay, I can kind of get it. Triangular truncation is just about putting those points into, or finding where the points are on an XYZ plane, which we've done a fair bit of. This part here, just the area of that is the rule always. So when you have 3 points, that will be the rule that you will use all of the time. When you have 3 points, and you're trying to find the area of a triangle when they make up those 3 points. So we could have 3 points here, A, B, and C. That will always be the rule. You guys know how to do these ones down here. Cross product here on your calculator. Just use cross P. I would define these vectors before you do it. So cross multiply instead of having to go and worry about them. Define them. There you go, there, to do the magnitude. Hopefully you can hopefully it's not too arduous to kind of figure that out. And then you've got this, then we've got all this. Got all this information, you kind of finish it off. Worded question, worded answer. You could say, the total surface area is going to be this. That's the question. If you have any questions, please let me know. Hopefully it all makes sense, and we'll chat soon.